welcome back to my workshop and welcome back to my channel. It's Carl. Just having a nice brew out of my brand new lovely cup. Wild cinnamon and apple. Very nice. Yeah, look at this. I was the very lucky recipient of the Haxby Shed mug in Paul at Haxby Shed's drawer. So get yourself over there. If you're watching me, you should certainly be watching him. His channel is fantastic. He does lots of machining and welding. He's got a really nice shaper. So go and check him out, and I will continue with my lovely brew. So we're handheld today, or at this moment in time anyway. So the usual disclaimer applies in terms of motion sickness, and also please do accept my apologies for the buzzing noise. The next door neighbour has decided to mow his lawn, but never mind, we'll push on. So what I've been doing today is doing some preliminary work on dismantling further the milling machine, and I want to show you now some of the bits and pieces that I'm going to be working on and some of the vagaries of this 50-odd-year-old beast. So what I've just done here is I've taken off the coolant pipe. You can see a piece of it down there, and it's just brass with BSP thread run into the ends and then screwed into the various components. So here we've got a box with lots of bits in it. That brass block fits onto, well, you can see where it goes there in the shoddy paint job that's on this thing, and that brass block has threaded into it this quarter turn valve that you can see here, and various other bits and pieces screwed together to make up the coolant pipe that runs up the side and then feeds onto the work table. So we'll put that over here for the time being. Now I just want to show you this drawing here. This is the manual that I think I've shown you before, and I've just been doing some preliminary work. Here's my first best scriber, second best pointer. I've just removed this 8th BSP plug here from the base of the vertical head because I'm going to take that off next. It's the next big assembly that I want to remove. So here is the vertical attachment. Handheld again, so the usual disclaimer. Although Matthew Luck of Luck Creations has been doing a lot of handheld work lately, and his videos are excellent. If you like what I'm doing, I urge you to look at him. He's rebuilding a Land Rover, and he's much better than I am. So as I said, I have removed the offending 8th BSP oil plug from the base of the attachment and drained all the oil out. That's how much was in it. Not very much at all. Now that's supposed to be Shell Vitria 27, which according to my research has been replaced by a Shell ISO 37, Tellus 37. Vitria is a pre-ISO designation. Now that's supposed to be an anti-wear oil, and it smells like a gear oil to me, and it looks a lot thicker than I would imagine a 37 to be, but you know, if that's what it's supposed to be, then I guess that's it. So inside this part here, there is basically just a geared transfer from the driving feature of the spindle of the machine proper up to here, to where we have then a set of bevel gears in here, and I'll show you that on the drawing in a minute. So I think I'm going to have to use the engine crane to get this off, much as I dislike using it in here. This is going to be a heavy lump, it's cast, and there's a lot of gearing and bearings and things like that inside it, so I don't fancy my chances. You can see here you've got these two, on each side there's two SHCS UNC screws, there's two on the other side. Take those two out and then remove this drawbar at the rear here, which is only hand tight at the moment, and then the unit itself, the vertical head, should pull off the ISO 30 taper that's in the spindle in the driving feature, and then we can get that off. Now I think that as I say, I'm going to use the engine crane to do that because I don't really want to drop it onto the ways, which I know they don't look great on the knee there, but it's mostly cosmetic. I think that sort of the state of them at the minute. So I'll show you the drawing now, and you can see how this thing works. So here is the drawing that I have of the vertical attachment. Excuse the quarter drive ratchet handle there, I just left it in for authenticity. So you can see here what I was talking about. There's the plug that I removed, the 8th BSP plug, to drain the oil out of the unit, out of this part of the unit at any rate. So we have on the right hand side here this stub shaft, which has an ISO 30 feature on it that goes into the driving feature of the spindle. And then we have these two gears to transfer the drive up to this level, which then goes into this portion of the unit, which is bolted on with these T-bolts that allow you to swivel the head itself. And there's a dowel which you use to maintain tram if you do move it away from 90 degrees to some other angle, you can reposition it with a dowel. I'll show you that in a minute. So these two gears here obviously then drive up through this shaft, and then you've got these bevels or mitre arrangement, and then in here are the gamut bearings for the spindle itself, the milling spindle, which has an ISO 30 feature in it, and this drawbar here, a short drawbar, which is to pull in the chuck or the collet or whatever you fit into here to drive the tool. So these gears in the low speed version rather, they're both 51 teeth, so it gives a one-to-one drive through here. And then in the high speed version, that gives an increased drive, so that the bottom one is a 66 tooth and the top one is a 36 tooth, so it gears up the drive basically to increase the speed. Now I'm just going to give you some figures what that is. Just give me 1 second. Yeah, so the high speed is about 120 to 2750 RPM, and the low speed is something like 82 to 1850, I believe, is the difference in speeds for that. So we'll go back to the head now, and we'll have a look at some more features, and I'll show you the dowel. So this is the dowel I was just referring to. It's a tapered pin with a thread on the end and a nut, and kind of counterintuitively, if you want to remove this, you tighten this nut up and it pulls the pin out, and I'll show you that now. There is some damage on this which I'll give you a peek at. So I'll just get my I've drunk my brew, that's no good. Let's get this what have we got here. Yeah, what size is that? Just show you, 5/8 AF. So we'll get that on there. Now I've had this out already, so it should come out relatively easily if I turn it the right way. Right, I think it's going to pop out now. No, let's keep going, give it a go. Yep, there we go, that's got it loose. Right, so there you go, one taper pin, which doesn't seem to have any scoring or damage on it, despite that line that you can see there. I think that's just in the grease. Now, what you're supposed to do with this is when you put it back in, you're meant to undo the nut so that it's right at the top and protects the threads, and then tap it back into engagement. And I think someone's just been hitting the thread. When I first saw this, I thought someone had tried to pin it, to lock it in some way, but I don't think that's the case. I think someone's just been a bit too free with the tapping stick. So we'll have to clean that up before that goes back together. So these are the T-bolts I was talking about that allow this head to swivel round once you've removed the taper pin, and there's graduations on here. You can move it, I think it's 45 degrees either side of vertical, and so that allows you to swivel it around. And then we've got a plaque on the side here that gives the speeds for if it's a high speed or a low speed machine, or head I should say. I don't actually know what this is. And when I take it apart and look at the gears in the transfer portion of the transfer gearbox, if you like, in here, that transfers the drive from the driving feature up into the bevels, I'll be able to tell you what that is more definitively. So I'm going to show you some more bits and pieces now. We'll have a look at the knee, and we'll have a look at the knee lead screw and the lead nut and the nut housing. So this knee is attached onto the vertical guides or vertical ways here by this clamping arrangement. Now, I've read up on this, and there's not much information online from other users about these machines. So I'm hoping this is going to become a bit of a repository of information, and my mistakes will help other people to refurbish these machines. This clamping arrangement here, which you can see at the front, has 4 SHCS holding that on, and then you've got the lock here as well. This doesn't have any gib strip in it at all, and I'm told, or I've read, that there are shims in this gap to set up the clearance or the fit between the clamp and the ways there, or the running faces here. And I'm kind of loath to take this apart, but I think I'm going to have to get this off to just to clean it up really, and even just to paint it. And I think nothing ventured, nothing gained. I think I'm going to try and split this apart and take this off. If it's shimmed in there, then it might be difficult to get the clearances right, but you know, there are ways and means of going about these things, and I think we'll have a go at it. So the same on the other side as well. We have a little bit dark around this side, apologies. We have, you can see there, the 4 SHCS, the lock, sorry for bumping the camera, it's even worse than usual, and obviously the lubrication fittings, which the Zerks, which we've got on the other side as well. So the thing I want to show you now is one of the parts I'm going to have to manufacture for this machine on the lathe is the lead nut housing. As you can see, it's cast iron, and a fairly substantial crack here has led to this this damage. So there was a lubrication nipple in here, and obviously the crack's propagated from the threads. They've been the stress razor that's caused this crack. So that's got to come off and get measured up and have a new one manufactured. There is another crack in it as well, around 180 round from this one. So that lead screw has to come out, and the operating mechanism with the skew gears inside here, inside the knee. You can see how filthy that is in there. It's just years of basically grease and swarf and other detritus that's managed to work its way into there, so that's all got to come apart as well. And another thing I want to do is, I kind of was going to leave the gearbox alone, but I am going to strip it down and replace all the bearings. And I've got these caps here. You can see that there's a thread in that hole, and then there's a locking grub screw on the periphery, so I can actually thread something into there to pull these caps out, which are the bearing caps. Inside there, there's a bearing for one of the shafts in the gearbox, and I'm going to make a simple puller to get these out on the lathe. So basically what I've got here, I'll show you now, is some nominal bore hydraulic pipe which fits over there, over the cap, and I can machine that, or basically cut a piece of that, and then take a piece of flat bar, weld it across there, and then I'll drill a hole in it, put a piece of threaded rod through with a machined end with the thread that's in there. I'm not sure what it is. It's a UNC. I think it's probably quarter UNC or maybe slightly bigger. And then we'll be able to make a puller to get that out. It does seem a little bit overkill. I know you probably say, why do you use a big socket? I haven't got a socket big enough, but I have got a lathe and a TIG welder, so I can make something up. Which makes all the difference, actually, I think. Being able to make just ad hoc one-off tools to do jobs like this, it's just a little bit more professional, and it makes the job go much more smoothly, I think. can see where we're at today, or it is a different day. We've now got the engine crane in position to lift the vertical head off the machine. I got it slung here with a couple of 1 ton strops, overkill, but there you go. We've got one doubled up around it, the other one's basketed through and on the hook. So we're going to take the weight using the engine crane, the dreaded thing that I don't really like using in here because there isn't an awful lot of space, but I haven't got any choice to get this off. We'll take a little bit of weight of this and we'll take the 4 SHCS screws out and we'll get this off. So now you've seen the arrangement, I'll bring you in a bit closer and we'll get this beast off. So here we are, slung as I suggested, or as I mentioned to you before, on the engine crane. This slings twice round and then this one's through the eyes and then into the hook. So this is held on with 4 7/16 UNC SHCS screws. I've taken the top 2 on each side, or the top one on each side out already, so that obviously once I've got the sling on I can't actually access them, so I've taken them out prior to slinging it up. So it's now being held on by these 2 at the bottom, the 2 7/16, and also by the drawbar that's going through into the driving feature, the ISO 30 feature in the back of the transfer box. So here we go, there's a 5/16 AF socketed Allen key. We'll get these 2 7/16 out to the bottom of here, of the bottom of the unit itself, the vertical head. Put them in there, get this one out. There is some kind of a dowel here in this position, hard to see I know, but I'll show you it shortly. We'll get this one out and then we'll try and see if we can get any movement on this. Now there should not be anything holding it now. I can see there's a slight gap starting to open up at the side. Let's just see if we can get any movement with the old the Thor. Yes, I am Thor, I better put some cream on it. Okay, so, right, gap's opening up, so it has definitely opened up there. There's a little bit of weight on this, not much. Oh, I've got some movement there, that's good. That means something, doesn't it? Right, let's undo the drawbar and see if this is going to come off. So that's the drawbar out. Put that somewhere safe, we'll put it on the bench for now. Right, right, I'm going to give this a tap. Right, that's definitely pulling away from the driving feature. So I don't want this to fall off onto the ways. Right, I'm going to show you what's in here now, because there's definitely a locating feature there as well. So I'm going to bring you in on the small tripod. That's what we'll do next. So that's me brought you in on the handheld. You can see there the dowel, or whatever it is I was talking about. It looks like it could be a dowel. You can see where I've removed those 2 7/16 UNC bolts. Now coming around the side, you can see the gap is starting to open up and the head's coming off. Inside there is a locating feature. You can see that there, that ring. So we'll carry on. We'll get you back on the tripod because I want both hands free for taking this off. There is some load on the sling. I don't want to load it too much because I don't want to jam it up on the locating feature or on the driving feature. So I'm just going to leave it like that at the moment. And this is slung in such a way, the way this is doubled round, that it shouldn't slide out. The vertical head won't slide out of that slinging arrangement. But once I've got this off, I'll get it down onto the deck as soon as I can. But I'll transfer you back to the big tripod, and so I've got both hands free, and we'll carry on with the operation. Okay, that's you guys back on the big tripod again. So I'm now going to remove the vertical head away from the machine body, which may take some doing because this engine crane is perhaps not the most manoeuvrable of things. Right, this is starting to come off now. I think I'm going to take a bit more weight. That's definitely moving. Yeah, I'm going to take some more weight on the crane, I think, because I really don't want that dropping onto the onto those ways. So you can still see what I'm doing. I'll just get a bit of weight on the crane and also observe the head and see what it actually does when it's got a bit. Right. Yeah. Oh, yeah. We're off. Right. That's the ISO 30 taper just come out there now in the stub shaft. So I'm going to put you on the small. In fact, no, I'm not. I'm going to pull this back, get it out of the way of the machine, and then I can show you properly what we've got. That's actually quite nicely balanced. Quite pleased with that. Let's get it away from those ways, and then we'll have a look at what we've got with it suspended from the crane, because it's not going to go anywhere. Ah, right. Okay, right. I'll put you on the small tripod and we'll have a look at what we've got. Right, so that's you back on the small tripod and handheld. So here is the driving feature, the ISO 30 fitting, which would have the horizontal milling arbor fitted into it normally. And you can see here there's a locating hole where the dowel that I was talking about went into, and then you've got the four 7/16 UNC threaded holes that hold on the vertical head. And this is the locating feature I was talking about, which is actually the bearing cap for the for this end of the driving feature, for the horizontal side of things. So now we'll spin you around. We'll have a look at the vertical attachment. So that's nicely balanced on there. Actually, I'm quite pleased with that. I was a little bit worried that it was going to fall over or it was going to tip, but thankfully not. So if we go around the other side of the vertical attachment, okay, there's the mating face. This is where it locates onto the bearing housing, which is the locating feature on the driving side, the horizontal arbor side. Here is the ISO 30 stub shaft that I talked about on the drawing, and that's not coming out. I think that's got a circlip or something on the other side of that stub shaft. Anyway, that on the other side of that is a 51 tooth gear. So we'll get into this in more detail later on when we come to strip it down. But that's what we've got in there so far. We've got an ISO 30 stub shaft, and that engages on that ISO 30 driving feature. So that was a lot less painful than I thought it was going to be, extracting that vertical head. So I'm really pleased I've got that off now, and I can start looking at the strip down of the gearbox, because you can see there this bearing cap here for the gearbox was partially obscured by the vertical head, so that had to come off before any further strip of the gearbox could take place. And I'm just looking, actually, the dowel I was talking about is recessed. So I'm not too sure what's going on with that, because there is definitely a hole, a corresponding bore there for that dowel to engage with. So we'll maybe have to have a look at that as well at some point in the future when we start stripping down the vertical head and examining the parts inside it. See what's going on with that dowel. Right. That's a good job done. I'll now get this thing down to terra firma and get it housed in a nice box. Keep it out of the way until we get the chance to do some more work on it. So you find me just spending some time cleaning out the threads in these plugs so that I can get some measurements and get some dimensions to make a puller for them to get them out. So I've just been basically blowing them out with compressed air, because like everything else they're absolutely full of grease and swarf. I'm giving it a spray with some aerosol solvent as well. Now, I spent a lot of time on the saddle and the table of this machine cleaning out all the grease, all the lubrication lines, the oil lines, cleaning out all the grease from them because they were absolutely chock-a-block with grease. So that was a long protracted process with pipe cleaners and blowing them out with compressed air, chasing them out with acetone or solvent. But in the end, I managed to get it all out. So I'll have a look. I'll put a tap down these threads. As I said, they are 5/16 18 UNC. Everything on this machine is either UNF or UNC, so it's all unified. So that seems clear enough in there now. And let's try this one. Yeah, just getting all the swarf out of it, all the dirt and grease. Right, that's good. So I'm just going to try and measure the depth of the thread in there pretty roughly, just using this little depth gauge. It doesn't have to be that accurate. It's only going to be for a puller, and you know, let's use the level of accuracy that the task dictates. So that is 8mm of thread in there, and about the same on that one as well, I think. Yeah, 8mm of thread, which is okay. It'll get a good hold at that. And then just measure the OD of it, just to see what, well, it's not a very exact measurement, but just trying to get an idea of the size of tube we can use. 48.7, so we'll call that 50. So basically anything with an ID slightly bigger than 50mm is going to be fine to make our puller out of. So now we've got some basic measurements. I'll take you over to the whiteboard and the workbench, and we'll have a look at the sort of idea that I've got to make a puller for this task. So here is a rough sketch, very rough some might say, of the puller that I want to make to extract these the bearing caps in my Harrison mill. So here's the bearing cap in red with the thread through the center of it, which is 5/16 18 UNC, and I took a slightly more accurate measurement of it than the one you saw me do, and it's 47.4mm in diameter. So what I want to do is to have a piece of tube like this with a bar welded across, a hole in the center of that bar, and then a piece of M12 threaded rod with the end turned down to 7.938, which is the dimension, the major diameter of the 5/16 UNC thread. And then we'll put a 5/16 UNC thread on that, so we can thread that end into the cap, and then we can put a nut on the end of the other end of this M12 threaded rod, and then by turning the nut that should extract the cap. So what I want to do as well is use on this piece of flat bar here, we'll face a 60.5mm wide area, so that this tubing here can sit into that, recess into that by about 1mm, and that's just to help weld it in place, just to give it some location, a locating feature to weld it when we TIG weld it. The TIG welding actually will be reasonable, but at the end of the day, all of the forces on this thing when it's pulling this out are going to be compressive. So that's actually to hold it, just to hold it together really. So this bar that I'm going to use is 25mm wide. So we'll chuck this up in the forejaw. We'll drill the 12.5mm hole through the center. Then we'll do this spot facing of 60.5 by 1. Now I'm using 60.5 the dimension for this because what I'm using as a tube is 304L Schedule 10S 2-inch nominal bore hydraulic pipe. And to keep the dimensions metric, When you're using nominal bore pipe, you get into all kinds of mixtures of metric and imperial, so we'll keep it metric. The OD is 60.33 millimeters, the wall is 2.77, and the ID is 54.79, so that'll be fine for straddling these plugs. And I'm going to make this 60.5, this spot face, just so that recesses in there quite nicely, but leaves a bit of leeway for welding it up, so it's not too tight. And I'm hoping that this will do the job. So what we'll do next is we'll have a look at actually making this.